So we are using the side angle side, or the SAS congruence theorem today. Let's learn about it. If we have two triangles, and in those two triangles we have two sets of congruent sides, and if we have the angle that is called included, if we have the included angle between those two congruent sides, that is enough information to say that these triangles are congruent. We do not have to find that all the angles and all the sides are congruent. This is a shortcut. Side angle side works if the two sides that are corresponding sides are congruent and the angle that is included between them. It literally has to be a side, the angle, and then a side. They have to be right in a row, just like that, for this to work. So if we have side angle side, we can go ahead and say triangles are congruent. So let's see that using a proof. Go ahead and fill out the first step. I know you can. You can do it. First step, I know you can. First statement and reason. I kind of feel like you should be able to do the fourth statement also. Yeah, to fill out the fourth statement. Fourth statement, do you know what to put for the fourth statement? Fourth statement. I mean, if you can fill out those three things, you've already found what's 3 out of 8. 3/8. What percent is that?
It's like 0.375 or something like that.
I think it's 37.5% of the proof you've already have done. You didn't even have to do much thinking. You are going to have proofs in your homework tonight, but they are fill in the blank. And they will be on big ideas, so they'll actually have like a bank at the bottom where you can drag the things that would go in whatever spot. Help you out. Okay, so sorry, I didn't do this one here. You guys were doing it. That would be what we're trying to prove. Triangle ABC congruent to triangle CDA. All right, next. If I know that BC is congruent to DA, then I would go mark it. It already is marked for me, but I would go mark it if it wasn't marked. And then, so that's two sides that are congruent. We also have BC parallel to AD. So you could see they marked it, but if it wasn't marked, I would. What does parallel lines give me? John? You're on the right track. There's a transversal that goes between the two parallel lines. What is that going to help me? I'm trying to get enough information to say that these triangles are congruent, and hint, it's going to be side angle side is the reason. So, you know, on a test or quiz, I'm not going to say, use side angle side. You'll have to recognize that. But right now we know, this is the first time we're doing it, it's going to be side angle side. So right now I have side. So now when I talk about parallel lines, what is that going to help me find? I need side angle side. What's parallel lines going to help me find? Your answer could be an angle, or it could be a side. So 50-50 shot, all of you guys wrong. There's got to be a reason why, and you were on the right track, John, when you said transversal. Because we talked about parallel lines having a transversal. Actually, I see 3 transversals. Somebody want to guess which transversal we would want to use here? What do you think, Lynn? AC is the transversal I'm going to use because what angles can we say are congruent now? Alex. Yes, and do you know the reason? Perfect. Those are alternate interior angles. So I'm going to say exactly what Alex said. Angle BCA congruent to angle DAC, alternate interior angles theorem. So we have our first side, we have an angle. What do we still need? We need another side. The side, in order for this to work, the side has to be included, the angle has to be included between the 2 sides. So you should know which side it's got to be. The angle has to be included between the 2 sides. Stephen, do you know what side? No, the angle has to touch the side. So triangle ABC is this triangle here. Maybe if I colored it, it'd be more obvious. We're trying to prove that this triangle is congruent to this other triangle that I left white. AC is the third side, or it's not the third side. AC is the side that helps, that the pink angle is included between, AC. So in triangle ABC, I will say that is AC. But in triangle CDA, what side will it be? CA? Yeah. Why? Right, that is the same side, so they have the same length, they have the same, they are the same. So reflexive property. And then you can now say that the triangles are congruent by side, angle, side. So that's your reason. You're more than welcome to write out the word side, angle, side, but that's your reason. Okay? In the diagram, QS and RP pass through the center of M of the circle. What can you conclude about triangle MRS and triangle MPQ? All right, I want you to brainstorm for a second. I want you to start thinking about anything that you would know is congruent by the information that's given here. Something that you would know is congruent. It's a circle. Have you studied circles before? Just like last week was the only time ever, right? Have you studied circles before? No? Did you make a pass around this? Maybe mark something on the diagram so I can tell where your thoughts are, because when I walk around, I got no clue when your paper is empty. What happens if you mark the wrong thing? All right. That's fine. There's something more that we're going to come up with from that. see a lot of you going in interesting places. Somebody tell me, what is this? When I talk about a circle, what is that? What is it? The radius. What is this? In a circle, what is that? Avneet, what is that? The radius. Raylan, what's this in a circle? This is the radius. Jesse, what's this in the circle? Radius. What do you know about the radius in a circle? Okay, I couldn't hear you. What?
It's half of the circle diameter.
Well, it's half the diameter, but that's not the part I care about right now. It's the same for every single radii in a circle. They're always the same. So just the fact that this is in a circle and it goes through the center. So these were diameters. The diameters are going to have to be congruent also. So these would be radii. So what can we conclude? We can conclude that SM is congruent to PM, which is congruent to RM, which is congruent to QM. Thank you. Because they're the radii of the circle. So if I were looking at this as the two separate circles that, just sit down, where that they mentioned that we had to say something specific about, there's one of the triangles. I'm saying the wrong words. The triangles that we had to say something specific about, there's one of the triangles. The other one I didn't highlight in blue. What do you think, in the section we're in right now, what do you think we're going to try to say? What do you think we're going to try to say here? That the triangles are, we're trying to say the triangles are congruent. Do I have enough information? I have side and I have side. Is that enough information? Side, side. No, we're studying what? Side, angle, side. Is there an angle there that is congruent, that is included between the two of these? Alex? RMS and PMQ. This one here and this one here. Why? Yes. Angle RMS is congruent to angle PMQ. Vertical angles are congruent. That's the vertical angles congruence theorem. So what can we conclude? We can conclude that triangle MRS is congruent to triangle MPQ by what? SAS. Almost done. In the diagram, ABCD is a square with 4 congruent sides and 4 right angles. R, S, T, and U are the midpoints of sides A, B, C, D. Also, RT is perpendicular to SU and SV is congruent to VU. Which proves that triangle SVR is congruent to triangle UVR. SVR, where is it? SVR is congruent to triangle UVR. I'm going to highlight these so I know what I'm looking at. Over here is a T. You can't see it because it got cut off by the hole punch. T.
All right, I like to start reading and, you know, maybe just start marking things. Four congruent sides, 4 right angles. So maybe I'll go ahead and mark those angles. R, T, S, U are midpoints of the sides A, B, C, D. So R is in the middle of BR and AR. So I'm going to mark those congruent. And these congruent. And these congruent. And these congruent. Why can I do all the same congruent marks for each side? Why could I do the same congruent marks here as I did up here? They're on different sides. How come? Maggie, do you know? Nope, not saying anything about a triangle yet. What is this original figure? And if I find the midpoint of a side, that marks these two congruent. And I find the midpoint over here, why are these the same tick marks? Why are these two congruent to each other? Because what?
Because they share right into the sides.
Well, that's not why these are congruent. Lynn?
All sides of the square are equal.
Like all sides on the square are equal.
So
So when I find the midpoint of any side, it's going to equal the same amount, right? Like if all sides were 4, then what would this little side be? 2, and what would this little side be? 2, and this would be 2, and this one would be 2, right? Because this is a square. So I'm just using the information that they gave me and like what I know about squares and what I know about midpoints. What else? So RT is perpendicular to SU. So RT and SU are perpendicular. And SV is congruent to VU. All right, so we have to prove the pink one and the blue one are congruent. I actually only need 2 givens here. They gave me a lot of stuff, but when I'm looking through, I only need 2 things. Do you know what they are? That was really fast, yes. RT is perpendicular to SU, and then SV is congruent to VU. That's the only givens I need. You can list more givens if you want, but that's all I need. Because now, if I look at my pink and my blue triangles over here, I have side and I have angle for both of these. Side, angle. What do I still need? So what they have next is VR congruent to VR. VR congruent to VR. Why is VR congruent to VR? Denise, why is VR congruent to VR? What property says that? The reflexive property. Oh, I guess I jumped ahead. These aren't proved congruent yet. Angle SVR and angle UVR are right angles. Why can I say that these are right angles from the information that was given to me? Matthew, why can I say that these 2 angles are right angles from the information that's given to me? How do you know that these are right angles?
Because they're perpendicular.
So I'm not going to write because they are perpendicular, but I am going to write something about perpendicular lines. Do you know what it is?
Definition of perpendicular.
Yeah. definition of perpendicular lines. And then this one you guys may have probably forgotten, so I'm going to tell you this one. Angle, actually I'll give you an opportunity, maybe somebody remembers. Angle SVR is congruent to angle UVR. I'm looking at these being right angles, and because they are right angles, they are congruent. Does anybody remember what tells me? Because they're right angles, they are congruent. Hi, John? No. They're both right angles, so they can't be complementary. Nah. Because we're not adding them up to equal 180. So the reason is there is a theorem or postulate. I cannot remember right now if it's theorem or postulate, but it's called all right angles are congruent. I think it might be like the right angle congruence theorem. I think that's what it is. All right angles are congruent. Right angle congruence theorem. Pretty sure that's what it is. If you have two angles that are right angles, then they're automatically congruent because all right angles are congruent. All right, last thing. A tiny little proof, just a teeny tiny one. Okay, but actually, this is the exact same picture. It's the exact same given as the previous page, and I copied the given in for you, so you didn't have to copy all that. Okay. It's the exact same proof. So where I was marking stuff on the other page, maybe we go ahead and mark some of that again. So why is angle B congruent to angle D? We were talking about why is angle B congruent to angle D? Here it says they are right angles. So why are they congruent? Why?
All right angles.
All right angles are congruent. It's the right angle congruence theorem. I'm writing all right angles are congruent because that's what I always wrote and that's what I'm used to, but it's the right angles congruence theorem. You don't need to put both, just put one of those. All right, BA is equal to DA is equal to DC is equal to BC. Up here in the given section, it says BA is congruent to DA is congruent to DC is congruent to BC. But down here it says, without a segment above it, BA equal DA equal DC equal BC. Like, what's it mean if there's not a segment above it? If we're talking about the measurement. So what we're trying to say is, how can I go from saying it's congruent to now saying the measurements are equal? Do you remember, Aaron? That's right. Definition of congruent. This would be segments for this one. If they're congruent, then their lengths are equal. All right, this one we should be able to get. However, it's been a while. But gosh, we have like a semester exam coming up, and all of this stuff will be on there. It won't like be one big proof, but like you'll have to know what this next thing is. It's all going to be on there. So it's great that we're kind of going over it again. BA equals BR plus RA. DA equals DU plus UA. DC equals DT plus DTC. BC equals BS plus CSC. Gosh, I can't read it. What are they talking about here? Let's just look at the first one. BA equals BR plus RA. John, you remember what it is?
Midpoint, it's called, definition of midpoint.
Nope. There's nothing here saying that these are congruent. All we're saying is that if I add these two up, I get the big thing. Avneet? Segment addition postulate. So that was like way back when we first learned how to prove any of it. That was like our first thing we were proving or using to prove. Okay, my next one is BR plus RA equals DU plus UA equals DT plus TC equals BS plus SC. Maybe a little highlighting might help you find it. You guys can do this. That's why I haven't said the answer yet. You can do this. Except for I've lost my highlighter, so it's not. Here it is. So in this statement number 5, it's all of these pieces equal to each other. Statement 5 is all of these pieces equal to each other. There's somewhere in these last 3 statements that allow me to put in BR plus RA instead of BA. You see right here it was all of the big ones equal to each other. Now it's all the little pieces equal to each other. What allows me to do that, Lynn? Substitution. I just took out BA and I put in what BA equals. I took out DA and I put in what DA equals. Substitution property. Okay, the next one is saying that segment BR is congruent to RA, segment DU congruent to UA, segment DT congruent to TC, and segment BS congruent to SC. It's like all of the 2 segments above that were added are now congruent to each other. Or we can go to the picture, BR congruent to RA, BR congruent to RA. What allowed me to mark those congruent in the first place when I read them? What allowed me to mark these congruent, Ryan?
It's all squared.
Well, that's why the big side is congruent. Why are these 2 pieces also congruent? No, that just tells me I add up the 2 and it equals this one. Why does the side of this not look like this? Like R there, B up here, and A down there. Why doesn't, it look like this? Why does it look like this and we have 2 congruent parts? What over here is telling me that these 2 are congruent? Yeah, it's because this is the midpoint, right? So I'm going to say definition of midpoint. All right, next one takes the exact same statement as number 6. It just changes it all to distance and equals. Changes it all to distance and equals. David's going to tell me this one. Yep, thank you. Definition of congruent segments. All right, now we have craziness. Here we go. We now have BR plus BR, DU plus DU, DT plus DT, BS plus BS are all equal to each other. What allows me to go from step 7 into step 8? Matthew? Yeah, substitution. Because BR equals RA, we just took out RA from way up here and substitute it with BR. Substitution. When you guys do these proofs, you really have to think about them in order, too. You can't just, like, look at this. You have to think about order matters for these questions. Number 9. No, I don't know the reason for number 9. Number 9, I mean, I know why that works, but I feel like it's the distributive property. I'm gonna double check this because I forget now. This is the distributive property. This is the distributive property. I'll show you why. If I have BR plus BR, oh, shoot. BR plus BR, I have like 1 BR plus 1 BR. If I undistribute the BR, if I factor that out, I have BR times 1 plus 1, which is 2 BR. That's why it's called distributive property. If you called it collect like terms or simplify, that would be fine as well. All right, from this big old equation to number 10, how did we get from this one to number 10? From number 9 to number 10, what did we do? Maggie, how did I get from number 9 to number 10? You don't have to tell me the property. Just tell me what's happening from number 9 to 10. They're equal to each other in number 9. Well, yes, I understand what you're saying, but like, how did it change?
You got rid of the 2's. And you just
Right. The 2's are gone. So now we think with an equation, how can we get rid of times by 2? Division. So we're going to do the division property of equality. Oops, I put congruence. Equality. That's how we're going to get rid of the 2. You're going to just do that, divide by 2 every term. Oh, we're almost here. BR, segment BR, congruent to segment DU, congruent to segment DT, congruent to segment DS. So I took all the equals, made them into congruent, took all the equals, made them into congruence, took all the equals, made them into congruence. The reason is on here 2 other times already. Didn't you say it last time? I'm not going to call it you again, but thank you. Jesse?
definition of congruent segments.
Yes, definition of congruent segments. Okay, and then finally, triangle BSR congruent to triangle DUT. Triangle, I never even marked what I was proving in the first place. What is it, BSR? Congruent to triangle DUT. What do we have to prove these congruent? That's a yes. Okay. The assignment is on big ideas. The majority of the assignment will be, well, there will be a few proofs, but they will be like drag and drop, fill in the blank. It won't be 100% by yourself. And then some of the questions are just like, what is the angle that is included between these two sides? So there should be some easy questions in there too. You have 10 minutes, 8 minutes. So you should log on.